Here we are at the IME West, which is the Automation and Manufacturing Conference in Anaheim. And I'm here for the Plastec portion of it mostly, but also robot automation and some packaging. So I guess I'm here for all of it. We're in Anaheim Convention Center in Southern California. It's a nice place. Here we go. You see some of the action. So let's go inside. Hello. Got these behind glass. That one seems not to be working. These are Panic. Palletizing robot. Rexroth. This is the company that has that little controller I was messing with. Robots everywhere. Here it comes. Got it.
And then integrator will use a third party and set it up. Okay. And then we would go with the program.
There's more robots. Hello.
We can do it out here. We're just a bed.
Look at these little guys.
Down the street from you guys.
Yeah.
So this is a two-part rubber injection molding.
LSR.
So the two liquid silicone rubber is the acronym. So the goo squirts to these. It mixes in a little screw auger right there, and then injects cold into a hot mold, and the LSR cures in the mold.
Yep.
And then it dumps out right there. And this is the boy extra small.
That's right.
So this can actually, I guess it can't fit on a bench top.
Yeah,
This
yeah,
is,
it is
oh really?
tabletop. This is the
Oh,
machine.
okay. Oh, so it's a bench top molding machine.
Correct.
Yep.
And the cabinet is optional.
And that's just a chiller to
a
keep
chiller.
the thing cold.
Correct.
Oh, okay. And then the power supply is there.
Transformer.
And that's just storage?
Storage. Yeah.
Oh, okay. Oh, there you go.
And mortgage.
But this still runs on 3-phase?
Yes.
Oh,
220.
okay. Cool. Is it ever possible to get it like into like a single phase? Like for an office environment? Oh,
Gotta
okay.
have the phase.
You have to have the phase converter.
Oh, okay. So technically you can, but you
Correct.
gotta buy some other big VFD or something?
Yes.
Oh, cool. Well, maybe one day I'll get one of these if I can fit it and justify it.
Vertical too, so keep
Yeah.
that in mind.
That is
not an
probably better
XL.
for inserting.
For inserting, absolutely.
Yeah, because when I was doing inserting, I had these 2 dowel pins, and I'd have to get them,
Yeah.
Just
and then
right.
make sure it didn't slip off the dowel pin. Where vertical is a lot better. Huh? Okay. Yeah, this is a cool little unit. So this is a smaller trade show. Normally, you guys would have your bigger gear out here. Or is this what you guys show now?
Well, we go from this all the way up to 125 tons.
Right, yeah.
So,
But like bigger shows is where you
MP
showcase that.
is primarily where they take the bigger machines.
Oh, I see. Got the ITN booth. This is their video of their molding machine. Here's one in action. This is 160 ton toggle clamp. Let's see if I can show in there. Nice and quiet. This is the injection unit. Hopper. Here's their second injection unit up here, vertical one. There's the nozzle. There's a lot of reflection on this safety window. I'm gonna go around to the back. Here's the back side of the same press. Let's see if we can see the toggle clamp. So the other machines I have has a hydraulic amplifier, but this uses basically like a big vice grip toggling clamp system. Pretty neat. Slides on this big old rail. Then you can put these picker robots on. This would take the place of the KUKA robots that I use. And you just bolt it on, and this little gripper will pull the screw out or get your part and dump it outside of the molding machine. Right at the bottom there is mimicking injection molding signals. So mold open, mold close, and all that.
Okay.
So that's how it's
So
working
this
with
is a
that.
simulation.
Yep.
That's cool.
So this is all electric. It's just
This is-
a massive
Best
screwdriver.
way I can put it is a 90% electric. What they did is kind of cool. So it's all electric injection, all electric clamp.
Yeah.
The ejectors, cores, and the carriage movement or nozzle contact force is hydraulic. So there's actually
okay.
a power pack down here.
Oh yeah.
So typically, if you have an electric
Or if you got
machine, you have to have an external power pack if you want to run cores or anything.
Yeah, like
What
cool.
ITN kind of realized, like, okay, well, you lose all this flexibility with a pure electric, right? Because you need some, if you want any valve gates, any cores, anything like that, you're gonna need some external thing.
Mhm.
So, okay, so flexibility there. Ejectors, kind of same game. And then nozzle contact force is really just like force, so you need to kind of keep it there.
Yeah.
So with the servo, you're just kind of wasting a bunch of money buying some servo that's kind of
yeah.
just fighting it. So
Yeah, you're just stalling out a motor.
so we kind of replace the simple movements with simple or like flexible type movements with this hydraulic power pack.
Oh, okay.
So you get all the precision of electric injection, electric clamp, but you get kind of the flexibility of that. And we also sell all true electric versions for medical customers, but we found this has been the golden kind of seller for the standard, you know, American molder. Like,
right,
cool, we get cleanliness of all electric, but we don't turn down core molds for contrast.
Right. Oh, okay.
So that's where this kind of came from. And then,
cool. That is neat to watch.
It's like a Mars machine, which is, or IME is based on the Mars machine, which is the world's most bought machine in the world.
Yeah,
So they,
yeah, I ran a Van Dorn in the
was it HT?
Yeah, so years ago, and the Wilson family in Ohio.
Al Wilson.
Yeah, and his two sons.
Oh yes,
they would come out and help service this like
too funny.
mid-80s Van Dorn.
So Van Dorn, Strongsville, Ohio.
Yeah.
Our tech center is in Parma, Ohio. Guess where we hired all the employees from?
From Van Dorn?
Our two owners are from. They were Van Dorn reps back in the day.
Right. Yeah.
ITN in early 2000s partnered with DMAG to create a new model of the machine, which essentially was the HT modernized, which became the Mars, which became the best-selling molding machine in the world. There's 37,000 made last year. And then they just added a second injection unit, and then you get your AFS.
Ah, there we go.
So it is quite literally you're following the train.
Yeah, it's
standardized molding machines. You went from pretty much that Van Dorn HT to the Mars to the injection unit and that.
Yeah.
Really cool. But yeah, we're pretty much from Van Dorn. That's our roots right there. So
yeah, I would agree.
Oh yeah, sorry, I'm just rambling about stuff.
Knock yourself out.
So there's no spinning magnets in here. Are they stationary?
Correct.
Magnets?
Everything's stationary.
Wow, it's probably a lot of current flying.
It's running on 60 volts DC.
Really?
Yeah, so
like 100
low voltage.
amps?
A lot of current. Yeah, a lot of amps.
So it's like car battery amps.
Yes.
Well,
So you can see the elevation.
Yeah. Huh. So is this like? So this is for like the massive puck factory line type of stuff? I mean, is this deployed in companies yet?
Yeah, if you have sporadic stations in your production line and you got to bring a product to one station and you can multi-directional get there from A to Z.
Yeah.
So it's a unique process. It's not, you know, it doesn't satisfy everything.
It's for like a.
You can see the convoy movement, right? See
yeah. So you can really.
So you can batch all four of them together and move it as one.
Huh. So this would be considered like a high mix work cell.
Yeah.
I mean, obviously you wouldn't have like these in a massive conveyor like a Tesla battery line or something.
You could do that. I mean, well, the possibilities are. I mean, there's a lot of people looking at for the packaging industry. Just to, if you have different types of products in different areas, you can bring them all into one location and group them, in different orientations or different packages.
This would be good in Vegas for shuffling cards.
Hell yeah.
Do these all have a RFID tag on them? How does it keep track of them?
Good question. So I found this out this morning too. I guess each magnet has a unique ID to it, just like your fingerprint does, by the way the magnet's responding to the coils. So we use that signature as the ID for each individual shuttle. And each one's different.
There's
I mean, if you took this magnet, if you took that magnet and take it to Europe, we'll know it's that magnet.
Really?
By putting it anywhere
but
you
it's
want.
not digitized. It just knows it's like the bullet
it's like your fingerprint or your retina scan. It's exactly the same.
Huh. Wow.
There's just a unique signature to any kind of magnet. And I didn't know that. And that blew me away.
Huh. Wow. This is pretty neat.
Yeah.
And then you got the hexapod up there.
Yep. Delta robot. So that Delta's being controlled by
Delta,
the same
is that what it
CPU.
Is?
Yeah.
Okay. Man. So you guys just integrate? I mean, you don't like sell this. You sell this package.
This is our product. So what we do is we sell this product to an integrator, and then they integrate it.
Oh, okay.
So we make the products themselves, the robot and the track system.
Oh, okay.
And we have integrators or partners that do the final solution.
Oh, okay. And that track system is magnetically coupled?
Yep. It's the same technology here. The track itself is the coil, and the shuttle is the magnet.
It's like a linear motor.
Exactly.
Linear motor.
It's like a linear motor.
Oh, okay. Well, that's pretty fancy. Huh. I'm sure I got tons of questions after I leave, but I don't know.
I mean,
I don't know what to ask you.
Go and come back. No, it mesmerizes everybody.
Yeah, especially the height. So I assume you're showing the max height.
That there is not max height. That's just standard.
Oh, but the accuracy or stability drops as you get higher and higher, I would assume.
Not necessarily, but you can only go so far.
Right.
You know, so you can only go so high because of the magnetic force. So
yeah.
I think I don't know the dimension.
R cubed or to the fourth, or is it 1 over R squared? I don't know.
You're killing me. You're going back to the college days.
Yeah. It tapers off quick, though.
It does.
Yeah.
So there is a limitation on how high you can go, but.
Neat. I mean, is this like $100,000 or 10,000 or you want me to turn the camera
somewhere in
off?
between.
Oh, okay.
Somewhere in between. I would say, I mean, there's.
And longevity is it's all basically solid state.
Yep.
So if your amplifier craps out, then you change an amplifier module, basically.
You got to change the plate.
Oh, the
Everything's
plate.
so tightly integrated in each plate, so and it heats up, you know, so there's a lot of heat being generated. That's why the cooling fans, you know.
Yeah.
So temperature can be an issue depending on how much you're running it.
So there's a bunch of tight magnetic coils that act like pixels, basically.
Exactly.
And it's just playing the kinematics and the servo.
So we're electrifying the coils to move the shuttle, the magnet, in whatever direction we want it.
You just have
So-
waves of magnetism that drive these and lock them.
Exactly.
Okay. Does it actually, I mean, we can't perceive it, but is there a popping action that happens?
No, the
Or it's
resolution
just-
on it is very, very high. I mean, things like holding 5 micron
Really?
resolution
These do.
in point-to-point resolution.
Oh,
So in the
okay.
positioning resolution. So it's extremely accurate. You can actually put a part on there and laser engrave it or do.
Wow.
It's a servo motor. It's a servo motor.
Yeah, basically
unwound.
just a linear servo motor.
Yeah. So
And
think of
your
it in that regard.
where you split the poles.
Exactly.
Micro stepping between poles.
But
it's
not
just
even
the poles are just individual pixels.
Exactly.
And you can.
That's the
you
way to
can
look at it.
Micro step between them. Huh. Neat. Oh, here's the wave. That's pretty cool. Thank you.
Yeah, you got it.
I was just looking for it because it kind of made us seem like you have like that.
Oh, okay.
It's fine.
Oh, thank you.
And do you want medium or?
I'll do medium. Oh, it's an espresso. All right, let's see this guy do it. I'm gonna have to get one of these. Oh, you got 2 different ones? Is that the medium and that's the strong?
No, she's just switching.
Oh, okay.
Yeah.
We can't have one because then they get overheated.
Yeah.
Oh, I see.
They still get overheated,
Yeah,
just not as often.
Production problems?
I'm still changing it like every hour.
Nobody makes that much chocolate.
And these are mass produced now? These robots?
Yeah, I mean, like if we sell like a bunch at the same time.
Yeah.
I don't know.
Or no, I mean, you're in production with these? These are, like, or are they still being developed?
Oh no, she has came out since like 2016. So
Oh, okay.
it's been a while. They're customers that bought it.
Is this all injection molded plastic? All of these linkages? Or is there like metal structure underneath?
No, it's injection.
Oh, okay. Neat. And if I just go to abb.com, I can
Yeah, or you can
figure
scan
out.
it here.
Oh, okay. Well, you scan my thing, so you're gonna send information. I guess I could phone scan that. Yeah, let me do that. I'll do that.
Yeah, you can do that.
Cool. And then it's done.
Yeah,
Oh, well, thank you.
no problem.
I'll scan that with my phone to get the
Okay.
website. Thank
You
you.
can also do it. It's in the cup. Here's a QR.
Oh, it's on the cup. Oh, perfect.
Okay.
Oh, there it is.
Yeah,
Okay.
can I try?
Thank you. This is a vibratory bowl sorter. See how it knocks out the parts that are not oriented correctly. And he's got all these little stations to let like wrong orientations fall through, and then it goes down a vibrating conveyor.
Yeah, you pour your garnet abrasive into here.
Uh-huh.
It holds 900 pounds of abrasive.
Yeah.
But yeah, we use about between a half a pound and a pound per minute
Okay.
of usage
All
while
right.
you're cutting.
And then it's just like super high pressure and garnet and water jet. And then this is full of used garnet mud, basically,
it's full of
right?
water, but yeah, eventually it's going to fill up with abrasive. You got to scoop it out of there.
Right, okay.
It's 60,000 psi of water pressure.
Yeah. Yeah, that Fireball tool guy on YouTube.
Yeah,
He uses this thing like crazy.
yeah, he sure does.
Sorry.
Have the backlight on, and let's say I just wanted to find fuses. We have different tools, like a blob is what binarizes an image, so
Uh-huh.
you can like search and it turns a certain grayscale value to dark or white purely,
Right. Yeah.
and you can choose like the grayscale value. So if you notice now they're more full, and like this is just it's picking up a mass. So like right here, all of them are touching, so it says this collective area is one part. So
Oh.
then I would need to set my criteria for like, oh, I only want to find these smaller parts. So then clearly these values are too large, and I start decreasing and I start finding. So like now the easiest way really would be like you isolate it to one part and you see what is the value that something that is good returns.
Uh-huh.
And then you isolate from that. So like this is the range I want to keep it at, like 62,000. So that means like probably within 50,000 and 70,000 is a great value.
And that's
then-
like pixels or something?
yeah, this is in pixels, exactly.
Okay.
And so then in that case, now that I've opened up and I say, oh, I want to find all the parts that are available rather than just one. Then when I
Uh-huh.
run this, you notice it just picked out all the parts
Oh,
and
cool.
it tells you the location. Now if I wanted to do inspection, there's something called like a geometric, which is you teach a model
Uh-huh.
and it detects the edge outline of that model and it tries to find that same edge outline in different locations. So now I'm going to isolate it to the singular object so you can see. And in fact, let's do one that has like better contrast, just because it'll help explain this better. You can actually see the model and see the outline of what it's picked out, and you can like reject certain things. So like if you
Oh, yeah, I
say
need that. I need
yeah,
that.
so like, oh, I don't want that, and this is noise, and you can avoid those, and it would just find whatever edges you have.
And it can orient the image
Yes.
to the master.
Exactly.
Like an edge find and then
Yeah,
figure out the orientation on the
Yeah.
randomly occurring.
exactly.
Oh, okay.
And so then these are based on a score criteria. So like I taught the model, and this, when I ran it, the singular object has a 978, and my acceptance is by default 700. So
Okay.
if I set the number to find a more than one, because it's always one by default, then it'll find anything that falls within that score criteria.
Well, I would have like parts on a conveyor that's slowly moving.
Okay.
And this thing would be able to notice a part based on the image that rolls in.
Yeah.
This is real time.
Yes.
And then it can figure out if that part is good or bad by
Yes.
the edge.
Yeah, you set the
discrimination.
quality. So like if let's say it's a geometric shape that is the difference between what good and a bad. Let's say you have like a comb, like a hair comb, and you have 20 teeth, and you know bad ones on average will have 1 or 2 minutes. Like it doesn't matter what, you teach one with all the teeth, and then you teach one with a bad model, and then whichever one comes back positive, you know that that's the that's the result, and so you handle the logic at that point. You would say,
and then you can tell, your software system would then tell this robot to grab the one that's bad.
Yeah, and do reject it or move it to a reject pile, or grab the one that's good and do whatever.
Okay,
You know?
and then
you choose the
so
logic.
this location data would automatically be loaded into the robot that'll pull out a bad part.
Yes. So you
okay.
you have to create a calibration in order to do a robot to vision data calibration, but that's part of a wizard also. So then like you would create a calibration, and then which we have done for our part feeding.
Yeah.
You essentially tell the robot, okay, it's a fix looking down, and it walks you through the process of what you need to do. And then you have a vision sequence where you teach certain points for the robot, it runs the sequence, and it creates that transformation between pixel units and robot units.
Right, okay.
Yeah.
And it can, and through this wizard, it can basically run continually as long as it's seeing parts. Or if it sees no parts, it just waits for this screen to say, okay, there's a good one, I found one.
Actually,
and then
the
next one is a bad one.
calibration. So that one wizard, so there's multiple wizards that do certain things, but eventually when you're ready to program, what you would be doing is you would be writing in your code, like if you want to run a vision sequence, it's V for vision and run, and then the sequence is called like test, for example, and then you want to get properties from it, so it's a V get. So from the test sequence, which is the recipe, I want to get the position from a geom object, let's say. So it's right there, geom, it tells you, you can just double click
geometry, okay.
Yeah, and then I want to get the robot XYU. So we go down here, and we would get that robot XYU position, and then pass that to a point, and then tell the robot to go to that point. So you'd have to handle the logic, but you're passing parameters. So like in this case...
and then I could just have this in an infinite loop. And
yeah, exactly. And then that's what would be running. There's no... I don't want to mislead you and make you think that there's a wizard that would handle the programming aspect.
Okay, but it's very simple program.
Yes, exactly. Exactly.
Okay, so there's a module that would say, bad part is located here. But then in the next line, I'd have to say, robot, move to that bad part location.
Yeah, you'd have to handle the logic. You would do a conditional.
Camera?
We support 4 cameras in our vision system.
Okay.
And you can always have, the max is 10 cameras, I believe. So you can have, that would be 3 vision boxes technically.
And this is your standard camera here?
Yeah, that's one of them. We have from 640 by 480 all the way to 20 megapixels.
Oh, okay. And how much is that?
That one is a 5 megapixel.
Like cost-wise?
Oh, I'm not in sales. No, I don't care. It doesn't matter if it's in a video. I'm not in sales. Actually, Mark, the gentleman right there.
It's less than a robot?
Yeah, significantly. Like I think it's like $500 or $600. But
that's
depending on the cameras. The vision box is what's expensive because that's the computer handling the processing of the. You know
and your
that
class that you have locally would teach me all of this stuff that
I would do vision and stuff. You don't have to memorize any of this, but you could do logic or if found then, and you do something, and then or an else condition. You know, it's just like Python. You can have if conditionals. You can do loops. You can do all that stuff.
Okay.
So yeah, it's just there's a lot of flexibility in the software. It's not wizards. It's not, you're not boxed in. But the problem with flexibility is if you don't know how to attack a problem logically, you can't get past the code because you have to know the logic of how to tackle a problem, which is with any programming language.
Okay.
Demo, or are you way out of it?
No, yeah, I can run it. Sorry, I was demonstrating.
And then you've got a big heavy steel base on this?
Quite a few in stock.
Oh yeah? Oh, okay. And you've just got flat pricing, I mean, since you've got it on your...
Yeah.
That's nice. I appreciate that.
Yeah.
I hate doing the used car sales
Yeah.
gimmicks.
Yeah, no. And with the price, it's the robot, the controller, and the software. You're basically
Oh, okay.
ready to run when you with whatever price you get quoted. It's not like other companies that
But
might
maybe
have
not
to
a teach
buy
pendant?
Not a teach pendant though. You have to supply your own computer. That would be
Okay.
like, the assumption is everyone has a computer nowadays.
Yeah.
So I've got a boatload of these in stock,
Oh, okay.
and I probably have at least 50 in stock.
Oh, nice.
So the lead time, what is that then? Like
Well,
weeks?
immediate then.
That'd be, well, nothing's immediate, right?
Oh, weeks, so not
a
months.
week to 2 weeks.
Oh, okay. Cool.
Alright, so then
So for me to actually teach this, then it would be clicking on a computer screen.
yeah, like
Like
kind
I'm
of
used to the
software.
like
If you have a
the
laptop,
teach
or
pendant.
you can get an optional teach pendant if you want.
Yeah, but you
Oh,
would,
okay.
that's an extra cost.
That's an option.
Yeah,
Like
it's optional.
$1,000 or
Well,
it's
the
on
one
your
that I would
website?
recommend for you would be $2,500.
Oh, okay.
What's
Like
nice
a
about
tablet.
It's similar to the other ones.
yeah, and it's drop proof and everything else. It's got a two-hand
Dead man switch.
dead man switch on it. You know, all
Oh,
that
okay.
kind
It's
of
like a
stuff.
KUKA one.
Exactly, just like
Oh,
it's
okay.
you know, robot anti.
Can I swap it between different robots?
Yes,
or-
you can buy
oh,
one and use them for all your robots.
So hot swappable type of.
Exactly.
Okay. Cool. Well, I like it. Yeah, this is exactly what I need. And all that machine vision you were showing me is because I need something that can look at a part and say it's bad and pull it
Yeah.
on a line. So thanks for watching my adventure down to the IME 2021 and Plastec 2021 conference in Southern California and Anaheim. Next week, I think we're going to get back to finishing up the robot work cell, and I'll stick that in the clean room and start populating it with robots and things. So thanks for watching. Please like and subscribe to the show if you enjoyed it. And you can also hit the little icon or the little bell icon to get notification.